In this bonus objective, we're going to talk about the graphs of exponential functions. So just as a reminder, an exponential function is when our variable x is in the exponent here. We have an a and a b. So a is the initial amount of our exponential, so where we start out, and b is the base, which is the number we multiply by each step. So when you go to graph an exponential, you would start off by just plugging in a bunch of numbers. So if we wanted to graph 2 to the x, I would graph points like 0, 1, 2, and so on. If I put in 0, 2 to the 0 is 1, 2 to the first is 2, 2 squared is 4, and so on. So that's going to give me these points here, 2, 4. All right, you can see as I plug in bigger numbers, I'm multiplying by 2 again. So if I plug in 3, I get 8, and so on. So I keep getting these bigger numbers as I plug in powers of 2. If I start plugging in negative numbers, remember that a negative exponent is going to turn this into a fraction. So it's going to be 1 over 2. Negative 2 would be 1 over 2 squared, which is 1/4. And you can see those values here. All right, so for 2 to the x, as I plug in big numbers or positive numbers, I'm going to get these bigger numbers out on the right side of the graph. For negative numbers, I get these fractions on the left side of the graph. All right, and this purple graph that's here, that looks like 2 to the x, or so this one is 2 to the x. This will happen whenever b is bigger than 1. So if I put in any base, it's going to look similar to this graph. The points will be a little bit different, but it'll look like that. So if I did 2 to the x, or 3 to the x, or 5 to the x, all of these graphs will look similar to the purple graph on this slide. It'll change and look like the black graph. So this black graph is going to end up happening whenever our b value is less than 1. All right, and this graph ends up being the graph of 1/2 to the x, which is basically the exact opposite of 2 to the x. But in that case, if I'm plugging in negative values, it's going to flip it to a whole number and then make the values bigger. If I'm plugging in positive values, I'm going to get these smaller and smaller answers. So if I were to graph 1/3 to the x, or like 0.5 to the x, or I don't know, 0.1 to the x, all these numbers, all these bases here are less than 1, so it looks similar to this black graph here. All right, so that's the first thing to know with your exponential graphs, is that if the base is bigger than 1, it's going to look like this purple graph going from low to high. And then if your graph has a base less than 1, it's going to look like this black graph, which goes from high values down to low values. All right, so that's the first thing you need to know. And the only other really thing is, remember that we have that a value at the front, which is our initial value. So for this graph, if a is 3, that means my graph starts at 3. Use a different color. And because our base, which is our b number, is 2, right? 2 is bigger than 1, so our graph is going to look like that. So it might be helpful to have just like one other point. So I'll plug in 1. 3 times 2 to the first is 3 times 2, which is 6. When I plug in 1, I get 6. And generally that's enough for me to kind of know on this direction, it goes up like that. You can always get more points. And I know as I go to the left, it goes down and levels off on the x-axis like that. All right, so that's a good enough graph. I have the x or the y-intercept correctly. There's no x-intercept because these exponentials never equal 0. So this is a good sketch of this graph. What about 4 times 1/4 to the x? Again, that a value at the front is going to be my y-intercept. It's where I start out for my graph. So I'm going to have that dot at 4. My base, my b value, 1/4 is less than 1. So that means my graph is the opposite of this one. The last one, it goes down like that. Again, it might be helpful to have some points. Let's try to plug in 1. I get 1. So if I plug in 1, I get 1. If I plug in negative 1, 1/4 to the negative 1 is going to flip to 4 over 1 to the positive 1, which is 16. So if I plug in negative 1, I get 16. And that's going to be enough to know that my graph gets big going this direction, hitting that point, and gets small going this direction, hitting that point. All right, so again, that's a good enough graph of this exponential. All right, so here's one for you to try on your own. 2 times 3 to the x. And you should have come up with something that looks like this. All right, first thing being that my a value is 2, so my y-intercept is 2. And then again, just to get a general point, I'll plug in 1. 1 will be 2 times 3 is 6. That gives me that point. And since 3 is a number bigger than 1, I know my graph has that shape. So I just kind of make that shape that hits the points that I know, and that's my sketch. All right, so for this learning objective, you're going to have to do a skill check. This skill check will be a little bit different than some of the other skill checks we've done. It'll basically be a graph that has a bunch of exponential functions on it. So you'll have this graph with some different exponential functions on it, and some equations. And you just have to match the equation to the graph. So if you know how to graph the exponential function, you just match it to the correct graph. All right, so that'll be your skill check for this learning objective.